Let's now take a look at trajectory. So first, the object moves in a trajectory motion from the point A, it goes right to point B, then it goes right to C. What is important is for us to actually resolve the velocity into two components. If the velocity of the ball is traveling at u, we resolve it into two components, uox and uoy. And obviously your uox will be actually equal to u cos theta, and uoy equal to u sin theta. Okay. And certainly not to forget, we need to make sure that we have a convention for both the x and the y direction. In this case, this is our convention. In a lot of these questions, they will be asking for you to calculate the y naught and the x naught, or for the time it takes for the ball to reach up to point B, or for the time it takes for it to reach up to point C. I think a couple of things that that we need to know. The time it takes for A to go up to B and B goes down to C must be the same. So if the time it takes for A to B is T naught, then from A all the way down to C will be 2T naught. Okay. So one of the key things that we also need to note is that in the x direction, the good thing is that since we assume there's no frictional force, in terms of the x direction, the acceleration is 0. Right? In this case, the ax is 0. So since the ax is 0, this is a very straightforward motion whereby the displacement is just basically the velocity multiplied by the time. In the y direction, obviously there's the acceleration due to gravity, which is minus g. Hence, we can deploy that in the respective formula that we have earlier discussed. And these are the respective expression to that. And now, typically in the exam, they want us to study point B. They want us to find out y naught. Okay. The first thing that we need to know at this point down here is actually that the v naught is the v naught y, or in terms of the finest velocity at point B, is actually 0 for the y direction. So if v naught y is 0, then you've got to deploy equation 2, where this is 0. So if this is 0, obviously your t naught will be uoy divided by g. This is important because the very moment we found t naught, in actual fact, we already know t naught and 2t naught. Okay. Then the next part is that to find y naught, okay, we can right away without calculating the time to use equation 4. By using equation 4, because we know again v naught y is actually 0. So if this is 0, your y naught is equal to u naught y squared divided by 2g. Alternatively, if you want to find y naught, once you have found t naught, you can take this value and substitute into equation 3. Because by replacing t with t naught, you can also find your y naught as well. All right, that's for the maximum height. The next part, now we come to the maximum range. Maximum range means how far this ball could travel in terms of the x direction. So in this case, we will now need to note that at a point here, so if I start out with the speed u, we know that when it returns back, it is still also u as well. So therefore, in this case, your v naught y is actually equal to your u naught y. So the initial speed in the y direction, they come back is actually the same as well. All right, as we said earlier, because there's no air resistance. Then the other thing to take note, which is important for understanding, is that if it takes the time t naught to travel up to here, it takes another t naught for it to return to point C, actually, all right, for it to return back to the ground. So the time it takes from A to C is actually 2t naught. So to calculate our x naught, actually, we don't have to deploy any of this equation. We have to just go back to here, because we already know that the time it takes for A to C is actually 2t naught, because we already calculated the t naught here. Okay, so we have to replace the t with 2t naught. So to remember, it's 2t naught, not t naught, and therefore this ends up as the expression. Okay, the next part we're looking at is how do we maximize the range that it travels, all right, by actually varying the angle theta. So as you can see down here, this is the mathematical approach, all right. You can take a look at it. And if RU squared sine 2 theta divided by G is the expression, then you find that if you want to maximize the value of R, quite clearly your sine 2 theta maximum value must be 1, and hence angle is 45. So it's important in exam that if you see exam questions that mention that they want a maximum R and the angle can vary, remember you'll be actually shooting the projectile at an angle of 45 degrees. In order to maximize the height, okay, or the height that the ball or the projectile could reach, in this case, the mathematical approach is here, right? And you have an expression h equal to u squared sine squared theta divided by 2g. In the same way, if you want your h to be maximum, you want your sine squared, the theta, to be of a value of 1. And from there, you'll find that your theta is 90 degrees, all right? So practically, it means that if you want to maximize your height, you should just be shooting vertically upwards. In the final part of trajectory motion, we'll be looking at horizontal trajectory, which means an object is being shot horizontally, and it starts off with UOY as being 0. Certainly, we still pick the convention as downward of y to be positive, towards this side to be positive as well. The key difference is that you can see that all this expression now, okay, will be 0, and therefore we can pare them down as such. And the other difference is also that in terms of y, we're picking downwards as positive, so it's plus g. Okay. One of the equations that typically is quite useful is to look at 1 and 3 when you combine them together. If you combine 1 and 3 and you try and remove the t, you're able then to express the y in terms of x. And that's pretty useful because in exam, it could be a case whereby they may decide to tell you what is the value of y and they want you to find the x. Or they will tell you what is actually the value of x. That means you're shooting a bullet, there's actually a board. So the distance between the board and the bullet is given. So you know the value of x, but you need to find the value of y. So the thing is that we'll now make t the subject, which is x divided by ux, and we will substitute inside this expression here. So y equal to half gt squared, and you can see that this is actually from equation 1. And then from there you come out with an expression as such.